This is the Discovering Density PostLab video. It's meant to help you figure out how to work up your data and answer any PostLab questions. In this lab, you collected masses and volumes for 5 samples of a particular metal. You either had a silver colored metal or you had sort of a goldish colored metal. In the PostLab, you're being asked to graph the data. I'm going to ask that you graph your data using a full page of your lab notebook as shown here in this picture. You should use a straight edge to indicate the Y and the X axis. Please make sure that you label your X axis as volume in the units of cubic centimeters and label your Y axis as mass in grams. You should also take note that you should be recording the 0 point at the origin as indicated here. It's going to be up to you to figure out where the number should go on the x-axis and the y-axis. Take a look at your volume data in your data table. What's the largest volume that you recorded for any of your samples? Make sure that your largest volume is reflected somewhere up here, as far to the right as you can, and then you're going to have to figure out what those intervals are going to have to be along the x-axis. Same for the mass on the y-axis. Figure out what your largest mass was of the 5 samples. Try to make sure that your largest mass is as high up on the y-axis as possible. And then from there, you're going to have to figure out what your intervals are going to be. Once you have your intervals figured out and written down on your x and y axes, you can go ahead and plot the data of mass versus volume from your data table. Hopefully you have 5 data points that are showing a general trend of going up and to the right. Perhaps it looks something like this. Everyone's data is going to look a little different, but now we're going to want to, yes, sorry about that interruption. You're hoping that your data somehow shows an upward positive linear trend like the graph shown here. Once you have your data points plotted, you're going to try to draw a line of best fit. You want to use a straight edge here. Please include 0, 0 as one of your points, because if your metal objects have 0 mass, they will also have 0 volume. It's just a given the point 0, 0 needs to be included in this graph. You want to try to make a line of best fit so that an equal number of points end up on the right side of this line as they do on the left side of this line. And you want to try to balance that line as best as you can. So you're going to have to sort of eyeball where the ruler straight edge should go. Go ahead and draw that line when you have figured that out, where the line of best fit should be. And it should end up looking something like this. If the line happens to go through a point, great, but the line certainly does not have to go through any of the points you just plotted, with the exception of your line should most certainly go through the point 0, 0. Once you have your line of best fit plotted, you will need to figure out the slope of your line. To do this, you need 2 points that actually fall directly on the line. Now this is sort of convenient because the point 0, 0 is most definitely on your line, so we'll use that as one of our points. The other point that I have picked out, I chose conveniently because it fell on the intersection of the graph paper. So this point right here, and I know I don't have my intervals marked very well here. I'm assuming you do. My intervals correspond to 1 block is equal to 1. And these are arbitrary numbers, but pick a point that is on an intersection of the line and you'll make your life a lot easier. So once you have 2 points picked out that fall on your line, write down their XY value as I have here in this picture. The next thing you'll want to do is actually right on the graph itself, go ahead and figure out the slope of this line. The slope is delta y over delta x, or you can rewrite it as y2 minus y1 divided by x2 minus x1. And in my case right here, y2, this is x2, my pen's not working really great here. x2, y2 is this point right here, and then my x1, y1 is the 0, 0 point. So y2 is 9, y1 is 0, x2 is 6, x1 is 0. So essentially, this is 9 divided by 6. Now, interestingly enough, the y values have a unit of grams, so the unit of grams should go in your numerator. The x values have a unit of cubic centimeters, so cubic centimeters belongs in the denominator. So 9 grams divided by 6 centimeters cubed is going to end up being 3 over 1. So the slope for this line is 3 grams per cubic centimeter. Well, interestingly enough, grams per cubic centimeter is a unit of density. It's mass per volume. So essentially, your slope of your line is equal to the density of your metal. And from this, we can, because density is an intensive property, we can use the density to determine the identity of the metal. So the slope of the line, which is in the units of mass per volume, grams per cubic centimeter, the slope of your line is density, and we're going to use the slope, we're going to use the density to identify the metal that you worked with. You're going to use question number 7, PostLab question number 7, which has a list of various metals and their slopes, which reflects the density of your sample. Now, your lab manual probably already has this written in, but if it doesn't, make sure that you include that the metal of aluminum, and I'm having difficulty writing with my pen here, aluminum has a density of 2.7. That's pretty crude, but that's a 2.7. So you may have aluminum in your sample. Now keep in mind, think about which metal you had. Was it gold colored or was it silver colored? The gold colored metals obviously would be gold, copper, or brass. If it was silver colored, it would either be silver, iron, tin, zinc, or aluminum. So based on your color, you should only be picking from those particular metals. Please indicate in a complete sentence which metal you think you had based on the slope or the density of your metal. Once you have identified which metal you think you have, I would like you to do a percent error calculation. The measured value is the slope that you calculated from your graph. The accepted value comes from the chart up above, and from that you should be able to figure out your percent error. For the follow-up for this particular lab, I would like you to write a summary, which, to rehash what your summary should be, a summary is a paragraph that tells me, not in bullets, not in numbers, in a couple of complete sentences, what did you do at the lab bench? Tell me about separating the metal out into 5 different portions. Tell me about weighing each of those 5 portions. Tell me about determining the volume of those 5 portions, and that you determine the volume by that method that we use, which is called water displacement. That's all you should be telling me about in the summary. In your conclusion paragraph, you should be telling me what metal you identified based on the slope of the graph that you constructed, because the slope of the graph you constructed is mass per volume, which is density, and based on the color. So you should tell me which metal you think you have based on the slope of the graph and the color. We're going to forego the two improvements section of this lab. So this lab will actually only be worth 13 points instead of 15 points. So we're just going to streamline this particular lab report just to get you practice in writing summary and conclusion. All right, hope this helped, and lab is due whenever your teacher told you it was due, um, which most likely is tomorrow. All right, thanks for listening. This has been the post lab video for discovering density.